Okay, so we did solve one example. What I'm going to do now is solve the same example. What I'm going to do, though, is I'm just going to use identities. So I'm not going to draw the unit circle. I'm not going to say, well, P is X and Y. X is cosine of the angle and so on, where the angle is drawn in standard position. Let's just use identities, okay? So again, what we're going to do is the same thing. We want to calculate cosine of theta and tangent of theta. Remember, we know that theta is between 90 and 180 degrees, right? So just like before, theta is in quadrant 2, right? Over here. So the only one that's going to be positive is sine. We're looking for cosine and tangent as well. They're going to be negative. And if you remember, sine squared of theta plus cosine squared of theta, we know has to be 1. We know what sine of theta is, right? That's 5 over 13. So we have 5 over 13, right? That's given to us squared plus cosine squared of theta is 1. So we want to figure out what cosine is. Okay, well from here, 5 squared we have over 13 squared plus cosine squared of theta we know is 1, right? Now 5 squared over 13 squared, that's 25 over 169. So this plus cosine squared of theta is 1. So from here, just like before, we're going to subtract, right, like so. Although you could probably guess it's going to be almost identical now, the calculation. It's just that instead of x here, I have cosine. So we subtract, we get cosine squared of theta is 1 minus 25 over 169. And just like before, 1 is the same thing as 169 over 169 minus 25. And as before, I won't show the extra step, but we end up with this. And so cosine squared of theta is this quotient, like so. So we have this now. Okay, so in order to figure out what cosine of theta is, we have to take square roots. Okay, so let's do that. So we have, again, cosine squared of theta is equal to 144 over 169. So if we were to take square roots of both sides, like so, we get this. Now the right-hand side, this is going to be square root of 144 over the square root of 169. So from here, we're going to get 12 over 13. From the square root of cosine squared of theta, just like before, we're just going to get cosine of theta. Just like before, meaning just like with x. Remember, though, you have to put an extra negative in there because cosine of theta has to be negative. So our answer is going to be this, which is really what we got from before. When we did not use identities, we went to the unit circle. And then in a similar calculation, tangent of theta is sine of theta over cosine of theta. And again, sine of theta is 5 over 13. Cosine is negative 12 over 13. And really, just like before, you get 5 over negative 12. And so tangent of theta is minus 5 over 12. So that's what we get here. So here's another example. Let's suppose we know that cosine of theta is 3 over 4. It might be a little hard to see, but this is 3 over 4, okay? So we want to get sine and tangent. And also, tangent of theta by assumption is negative. Okay, well then, how are we going to get sine and tangent? Well, notice that we know that cosine of theta squared plus sine squared of theta, that's going to be 1, right? Right, that's one of our identities. So plugging in, we get cosine squared, which is 3 over 4 squared, plus sine squared of theta. That's going to be 1. So what's 3 over 4 squared? Well, that's going to be 9 over 16. So what we have is 9 over 16 plus the sine squared of theta is 1. Okay, that's good. Now what? Well, we want to get sine of theta, so let's subtract. As you can see, we're subtracting. These cancel. So we have sine squared of theta is 1 minus 9 over 16. Okay, that's good. Well, remember, we want to calculate this. So 1 is 16 over 16. So we have 16 over 16 minus 9 over 16. Well, of course, that's just subtracting the numerators. That is, in other words, we get this. And this is just 7 over 16. But now the question is, we want to know, well, okay, what about sine of theta, right? I mean, from here, we know, so from here we get sine squared of theta, right? That's equal to 7 over 16. Okay, so this is what sine of theta is. But if you remember, right, we know that tangent of theta was negative, cosine of theta was positive, right? So if we go back to this, all students take calculus. So if cosine is positive and tangent's negative, well then we have to be in quadrant 4 because only cosine is positive. Hence sine is negative. So from the above, we get sine of theta is negative square root of 7 over 16. And so this is, of course, the same as sine of theta, negative square root of 7 over square root of 16. Square root of 16 is 4. So finally, we get sine of theta is negative radical 7 over 4. But let's actually calculate tangent, because if I remember correctly, we were asked to do that. Well, we know what sine is. We know cosine of theta is 3 over 4, right? And we know that tangent, by our identities, is sine over cosine. So again, I'm just really using identities here. So tangent is sine over cosine, right? So plugging in, we get tangent of theta is negative radical 7 over 4 all over 3 over 4. Okay, well again, we want to basically write this as one fraction, not one fraction in another. So this is the same thing as negative radical 7 over 4 times 4/3. I mean, really what's happening is you're taking the top fraction and dividing by the second fraction. Well, when you divide by a fraction, that's the same as multiplying by the reciprocal. So we get this, which is negative radical 7 times 4 over 4 times 3. Okay. Times 3, as you can see. So these cancel, and we get tangent of theta is negative square root of 7 over 3. So that's our tangent. This is, well, cosine was given. We calculated sine.